Hey everybody, John Wagnon here along with Jason Rahm on a Whiteboard Wednesday video here on DevCentral. And we were talking about some terminology and just some basic understanding of, hey, one company may call something one thing, F5 may call it something different. But we thought it'd be a good idea to have a quick video here to just establish some basic common ground terminology and just the ideas behind some of the fundamental building blocks of what makes up F5 terminology, as it were, in the networking space. And so with that in mind, we want to take a few minutes to go over just some of those fundamental key points. And so Jason will talk for a little bit, I'll talk for a little bit. Maybe he'll interrupt me, maybe I'll interrupt him. I don't know, we'll see how it goes. But so we'll start off with a few things that Jason, I think you had in mind.
I thought I got the opportunity just to stand here and look good, but
there's always that.
All right, yeah. So I'm going to start off, and we're going to climb the ladder from physical up to the higher layers of the stack, and we're going to start with the interface. And well, an interface is an interface, so there's not a whole lot to talk about on the interface. You have a big IP, and depending on your product, whether it's physical or virtual, you have a certain number of interfaces. And the interface is just an essential building block to get traffic from big IP and to big IP to other devices, whether they're switches or routers. And so you have the interface. And that's pretty standard across the board with every other vendor. And then you have the VLAN. And the VLAN is a layer 2 construct. And so where some of the terminology starts to go sideways is like in the Cisco world, you have a VLAN trunk, and the VLAN trunk in the Cisco world is more the link aggregation or the Ether channel. And so what we might do is we might take two of these interfaces together and connect it to a router, and then we bundle those. And so that's a VLAN trunk in the F5 world. And then we have what's called tagging in an interface. And so if in the configuration I'm setting up my interfaces and VLANs, and it's going to say how do you want to attach this? And so if this is an untagged interface, I might have VLAN 10 on an untagged interface, and that would be like a 1.6. Okay? And so what's going to happen is when Big IP sends traffic out, then it's going to send an Ethernet packet out on the, or actually an Ethernet frame to be precise, and it's going to send that out on the wire, and it's not going to have any 802.1 or 802.1q tags on that interface. However, if I have here, and I've put this together and say this is trunk 1, and trunk 1 I'm going to tag with VLAN 30 and 40 and 50, then our trunk, which is a link aggregation, is going to be tagged with these three VLANs. And in the Cisco world, what a tagged interface would be the VLAN trunk. And so there's a little bit of confusion between vendors, but that is the basics of how link aggregation and tagging works on the F5 product. Another option you have with the layer 2 on the big IP is what's called a VLAN group. And the VLAN group, you end up with, if you want to maintain a single layer 3 structure between two different VLANs, what you can do is you have your router, and say the gateway here is 172.16.1.1, and this is the external VLAN. You put big IP in here, and then you have your internal VLAN with servers whose IP addresses are in the range, and this is internal. What you do on the big IP is you create a VLAN group that bridges these two networks at layer 2 together. And so your self IP would be bound to this VLAN group. And then the big IP handles all of the bridging characteristics between the external VLAN and the internal VLAN for you. And then finally, as we're climbing up from the VLAN group, we're coming up from layer 2. We have the self IP. And the self IP is literally just an IP address that you bind to a VLAN or a VLAN group. And so this would become your, if you're going to do any kind of like auto mapping of NAT, it's going to be bound to either the self IP or in a highly available situation where you have floating IP addresses between your two big IPs. The floating address would handle, or would be what the NATing binds to. But when you're going to communicate to the big IP, or traffic is going to flow either from a gateway perspective to the big IP or through the big IP to another gateway with a NAT address, this IP address that's a self IP address for that VLAN or VLAN group is going to be the one that's there. And on the self IP, you can have multiple self IPs per VLAN or VLAN group. Also, you can lock down that port through the port lockdown. So you can lock it down to no services available, and that means that the IP is not going to respond to anything. If you do like an Nmap, it's not going to respond to anything. It's not going to run any services on those ports. Or you can allow, say you want to allow management connections. So you enable 443, or you're going to enable port 22 for SSH, and configure all those different services. Or if you have iQuery running between interfaces, you would enable 4353. And so you can either lock it down to nothing, you can open it up to a few, or you can say, hey, I don't care who connects to this port, I'm going to allow everything to connect to this big IP. Don't recommend that, but it's certainly something that you can do. And so now that we've kind of talked about the interfaces, VLANs, and self IPs, John's going to cover nodes and pools.
Yeah, so interfaces, VLANs, and self IPs. Oh my kind of thing. So the next thing, like Jason said, we're gonna introduce the concept of a node. So I'll just write the word node up here, and think of a node as say you have like an operating system, whatever, in 172.16.1.1. It's the node is basically just the IP address, or it's the IP address of a server, and so you could have several different services running on this. But the overall idea here for a node is just the IP address of that server. One thing you can do here is you can assign common monitors for general health perspective. Let's say you have different pool members in this node that as long as the node is up, then you don't. As long as the node is up from a health monitor perspective, then you're okay to assume that that pool or that pool member is going to be up as well. So anyway, so the node, very simply, is the IP address of a server. And then, and I kind of mentioned this a second ago, so you have the concept of a pool, I'll say pool member. And so what the pool member is the server IP plus the port. And so you may have a pool here, with the server, let's say 172.16.1.1, but then you may have port 80, you may have port 8080, whatever the ports are. So these are the services running on that. And so again, from a terminology perspective of the node, which is just the server IP, the pool member also includes the port of that IP. There's a few different types of pools that the big IP has. There are server pools, which would pass application traffic. You could have a gateway pool, which may have, say, router gateways included in that. Another one is a clone pool, which a clone pool you may use to just clone traffic off to do some analysis of it, or maybe you want to analyze some security specifics of that. So you may have a clone pool as well. So there's a few different types of pools that are offered in this entire big IP space. So anyway, so you got the idea again of node and pool, which is server IP or IP plus the service plus the port, which is the service that it's running.
And real quick on a pool, you might have whether it's the same port or multiple ports. If you have a pool defined in big IP and say that this is port 53 and this is port 8080 and this is port, let's say 52,375. It doesn't really matter what the port is, as long as the application that you're expecting is running on that port and you've defined it in the pool. Big IP will handle it and do that port translation for you when you've defined the pool IP and port member. So it doesn't have to be a collection of like ports. It can be whatever port your application spins up. And I supported an application in the past where on a single node, it would spin up 16 instances and it would separate by port definition. And so you would have 16 pool members, but they're all running on the same node. And it it handled all of its session handling in the app itself until we moved some of that application logic into the big IP. But it's totally possible to do that as well.
Yeah. So the big IP is pretty smart like that. Awesome. So we've talked about interfaces, we've talked about VLANs, self IPs, we have the concept of node, pool member, and then the last thing we were going to talk about is the virtual server, which is the kind of the fundamental thing that you need to pass traffic. And so anyway, Jason, you were going to talk about maybe a couple of them, and then I could share a couple of other examples.
Yeah. So basically, with the virtual server, and there's some confusion on this. People they get their configuration in, they have pools nodes, and they have a routing table that has their default gateways, and they're getting traffic, and it's like, I don't understand. I've got my routing table defined. The packets are arriving at the big IP, and it's not passing anything. What's the deal? And well, the deal is by default, the big IP is a default deny device. And so if you do not have any virtual servers running, it will not pass any traffic through the box. If you have self IPs defined and you allow ports to them, you can send traffic to the big IP and it will handle and manage that. But if you don't have virtual servers for traffic that's going to go through the box, the routing table doesn't matter. It's not going to pass the traffic. And so you have to define a virtual server in order for traffic to flow through big IP. And so there are, if you want to set it up just as a router, they do have forwarding virtual servers for that. There's an IP forwarding virtual server, and it will allow you to pass traffic through. You can do it by, the route all, which is a 0000/0. And if you add that, then boom, all traffic will flow through, no questions asked, as long as there's a routing table entry for it. Or in the case of auto last hop, if the big IP received it, it'll go ahead and return it because it builds a layer 2 forwarding table for that. And then, John, you were going to talk about some of the other options for virtual servers.
Exactly. So, like Jason said, there's a lot of different. There's the standard virtual server, which is just kind of the load balancing. Jason mentioned the IP forwarding. There's a layer 2 forwarding. There's HTTP performance virtual servers, layer 4 performance. There's stateless. There's a reject. There's DHCP. There's internal. There's a lot of different types of virtual servers that you can take advantage of on the big IP. So anyway, just wanted to make sure you guys knew there's more to it than just a standard virtual server.
Yeah, and if you're at this point in the video, you're probably asking, well, if the big IP is a default denied box, why would I need a reject virtual server because my traffic is already going to be rejected?
Yeah.
Well, the use case for a reject virtual server is, say that you have allowed this as I'm going to pass, which is pretty much all traffic. And so if you have that, and you're allowing all traffic through the box at layer 3, then that may not be something that you want. Maybe you want to say, for the RFC 1918 stuff, I want to go ahead and block. Traffic, and so you might block. And I forget the mask for that one, but let's just do an easy one. 192.168. And so you may put this in and you say reject. And so maybe you build a set of virtual servers that block all RFC 1918 traffic. And you say, hey, if I receive anything on this, boom, I'm going to shut it down. I don't want to pass that traffic. But you do want to pass anything that's public. And so that would be a use case for the reject.
Yep. Perfect. So again, frankly, the point with having all these different types of virtual servers is that it provides a lot of flexibility, a lot of power. And so anyway, we just wanted to make sure that everyone was aware of some of the terminology that's fundamental to the the networking side of what F5 does and just what we call things here. And so anyway, so it's great to know that information, and we would encourage you to get out there, dig into the big IP, look at it all, but again, we want you to understand what you're looking at. So anyway, Jason, I know I've learned a lot today. I hope these guys have, and we appreciate you joining us here today. And so thanks for watching this Whiteboard Wednesday, and we'll see you guys out there in the community.